Welcome everybody to another Interop webinar. Really excited to be with you today to cover our latest releases of our io.Intelligence product suite. I'm joined today by Krastev, our engineering lead for our io.Intelligence business unit and solutions, and Krastev, who's our director of AI solutions, also for the io.Intelligence business unit. For those of you that don't know me, I'm Bob Myers. I'm the Chief Product Officer here at Interop. So we've got an action-packed agenda for you today. For those of you that are joining and maybe don't know what io.Intelligence is in terms of an offering or capabilities that are available to you as an Interop customer, we're going to just do a very brief amount of scene setting about why we started the business unit, what our philosophies are, what we're here to help you with. Then we're going to focus a little bit on what we've recently shipped. The reason for this webinar is that we have a whole host of product capabilities that we want to make you aware of and that are generally available today, and I think can add a lot of value to Interop clients in the back half of 2026. Without much further ado, we'll jump into a capability demo from Krasi. So we want you to see the art of the possible. What does an AI-centric desktop look like? And that's io.Connect with io.Intelligence running actual workflows for you. So we'll have a nice demo there. And then we'll hand it off to Colin to really walk through the architectural overview. A lot of the folks on this webinar are more technical, and so we just want to give you a sense of how we built the solution and what you can take advantage of. It's a very modular and customizable framework that we've built out here. There'll be plenty of time for Q&A at the end, and we'll also talk a little bit about what's on our roadmap for the rest of 2026. So why does io.Intelligence exist? Interop is not inherently an AI company. We are still interoperability and workflow experts, but through that work, we've seen our clients various attempts to adopt AI and incorporate that into the enterprise desktop. And we saw that the foundations that Interop offers, whether that's application directories or ways to message between applications, actions, or handle context at a platform level, we felt like this was a large part of what AI needed to be useful in the enterprise. We saw plenty of examples where third-party vendors were introducing very siloed AI solutions into the desktop alongside of the enterprise applications, or we saw particular application owners internally taking the same approach. And so our philosophy here is most AI solutions are actually skipping a lot of the governance and benefits of a platform perspective. And we think that io.Intelligence, as an overlay to the io.Connect platform, can actually help our clients introduce a centralized and sensible AI solution in the form of assistants and agents alongside of the application estate that exists today. And that's what we've really been focused on here. So in summary, the foundation that you've all invested in of interoperability and having that platform builder perspective is incredibly valuable and foundational. io.Intelligence just takes those capabilities and ensures that they are AI ready. And really our goal is to build things that we see as common across our client base so that you don't have to. To put a different maybe perspective on this, what are we trying to enable? So for the folks on the call, you're going to be at different points in the AI adoption spectrum. Probably not many of you, but some of you may not have any AI solutions on the enterprise desktop yet. And if that's you, we give you the full stack of capabilities that you would need to build assistants, provide them with tools and governance, and really deploy that alongside of your existing applications. If you already have an AI assistant, io.Intelligence is here to make that assistant more capable and be able to take more useful actions on behalf of your users. And if you're well advanced in your assistant experience and you're ready to start deploying agents alongside assistants and your users, then the io.Intelligence framework is also beneficial in terms of building and deploying those types of agents. And again, our philosophy here is to help you sort of accelerate or maximize the investment that you've already made in your io.Connect implementation. There's no rebuild required. Everything works with your existing io.Connect platform and your interoperability investments. A quick note on where we see just working with clients the direction of travel for the user. It's important never to kind of lose sight of who's actually going to be using these platforms. And so before we talk about the platform capabilities we've built, what does work look like? And it's a basic observation, but work to this point, and certainly today still this pattern holds, is really about harvesting insights. So probably 80% of a knowledge worker's time is spent moving between applications, uh, manipulating data within them, kind of discovery. And the way I would describe this is harvesting insights. And then maybe 20% is making high value decisions and actually doing something with that information. And I think, fortunately for everybody, this paradigm is changing. And so, with AI taking a lot of that toil or that grunt work or just the toggle tax, the basic things we talk about, out of the equation, really it means that 20% of a knowledge worker's time is going to be spent on that harvesting, and 80% is going to be spent on high value decision making. Our philosophy is still at this point that the human absolutely is the accountable entity in this equation. They're in the loop, and so everything we've built on io.Intelligence is built around this idea of observability, governance, and ultimately it's about empowering your users as opposed to replacing them, for example. So just as a reminder, we had a large release on the io.Intelligence product suite at the end of 2025, and we've built on that since then. So the first release was just a basic set of capabilities. One was an MCP server that hooked into any chat assistant that you already had available, and it was focused on allowing large language models to pilot the io.Connect platform and also supported custom tools for your applications within them. We paired that with a really powerful module, which is our working context module that allows AI to actually understand the work that's being done on the desktop, which you'll see in some of the demos why that's really important. The recent release and the one that we're going to be spending a lot of time today kind of showing you what the capabilities unlock is a full stack. So everything from a customizable chat user interface, and as with anything that we've built at Interop, it's highly customizable. We'll give you a seed project and a starter kit, but then you're off to the races to build your own. If you've already got one, you can hook into the rest of our capabilities. We've got a backend capability, an AI server there that handles all of the backend orchestration that you need. And we've been spending a lot of time on embracing the latest evolutions of AI standards. And so one example we'll give today is a concept called MCP apps. So actually taking MCP tools, and instead of pulling data or context from them, you're actually able to return interactive applications. So really powerful stuff. And the summary here is at this point, we have generally available everything that your team would need to start building AI assistants and agents on top of io.Connect. And we hope that in this webinar, you'll contemplate that as opposed to building this yourself, which we think would slow you down. So we're here to accelerate your AI adoption journey. All right, so that's the quick preamble. Let's get into the exciting stuff. So I'm going to turn the screen over to Krastev, who's going to be giving us a live demo of what these capabilities actually look like in practice. So Krastev, over to you.
Sure, and if you can confirm that you see the screen now.
I can see it.
Cool, welcome. So you've may seen other demos of our io.Intelligence unit before. We've showed the world how to, for example, manipulate workspace creation dynamically based on natural language commands. We've shown you a lot of third-party integration with PowerPoint, with Excel, with Salesforce. What we haven't shown so far is how this works with your internal system, and this demo is an attempt to do that. So you see on the screen a little bit of a busy screen that a sales trader probably sees every day. It has a lot of widgets. It's running in io.Connect browser, so always running on the browser with zero deployment. You can offer this capability to your users now if you're still on desktop. A lot of micro front ends. Actually, this is not a demo of the window management, but you can, I'm gonna just quickly reorder some so we have more space for the interesting stuff. And the interesting stuff, as Bob said, is a ready to ship pre-built assistant. You don't have to use this interface if you don't like it. Everything in the io.Connect world is APIs and NPM modules. So you can take it, you can shape it, you can rewrite the UI to your own liking. So right out of the bat, I've just greeted the assistant. Just like in the old those days, the first thing you do is type //h to see the help or the available commands you can run, and it tells us what it can do. It deals with market data, it deals with charts, market depth, portfolio, orders, and watch lists. But the interesting part is actually here. He said here, and this is not hard coded. I am your trading assistant embedded in the Acme OMS workspace. So right out of the bat, the assistant, unlike let's say if you have Cloud Desktop or any OpenAI products, it understands the context it's in. It's in the context of an OMS. It's in the context of an io.Connect workspace, and also the clicks that I do in these applications, it understands them natively. It doesn't have to go to a server and do some retrieval augmentation stuff. So let's start with some basic stuff, and let's ask it to show me Vodafone, because this is the security that we're going to be trading and interested in today. And again, very simple, click to sync in the old world, and now it's maybe voice command or prompt to sync if you're going to be coining terms, but it synced the applications or the micro front ends that understand the context of security to the given security. The next thing I want to ask it is how is VOD trading? And this is interesting because you can see the two calls in real time. This is interesting not because of the data that is going to fetch to me. Nothing on the screen on the left will change because it goes to a backend service. So this is your run-of-the-mill market data service provider, which you're subscribing from Bloomberg, from FIS, from any of the other financial institutions that offer this. But it just goes to show that you can not only instrument front-end tools, which is the interop specialty, but also some backend services and run them in the background, for example, in case of a market volatility. What else we can do is, again, something that I can probably get with a little bit of clicking around the applications here or diving around, but data that is not immediately visible. Of course, you can get to the data. This is still your own data, but let's ask it to what is our exposure to Vodafone. Again, data you can easily get to in the old days of working, but it's just much faster. We think much more intuitively presented by an AI. What else? What else? The interesting stuff. So we can ask the LLM to buy, let's say, 500,000 shares at market. And it also has the ability to launch windows. It can launch them in the workspace. We have a whole new area of positioning. In this case, it opened this as a new window. I can add some instructions and send the order to the market. You also notice that I didn't have to specify which instrument I'm interested in. The LLMs these days are very intuitive into guessing what the context of the conversation so far has been. So I don't have to do, I can use colloquialisms. It's also doing what in the old world we call next best action. So it is already eliciting some of the further actions that we might take in our daily workflow and is giving us an easy way to do this. And yes, we want to check how the order is feeling. Again, the interesting bit is not that you can query an LLM or just another UI to get to the information, but this demo is also running one of our products called IO Bridge, which means that you can do this while you've placed the order and you're walking back from the water cooler talking to your colleagues, for example, which is a really interesting use case for us. It's also eliciting us to see the executions. So yes, again, we want to see the execution so that order, I don't have to specify which order, it already knows. It opens another micro front end already pre-filled with the context and the information we need. And as you can see, there are simulated fields running it in real time, so it's already updating. We cannot get away, of course, from showing you some third parties for the purpose of this demo. Again, the interesting bit is we have Excel in the background, so let's ask the LLM to export the last 10 field orders to Excel. And again, you can see me using colloquialisms because the LLMs these days are very smart, very in tune to your own way of talking. You can talk to them however you like. So it's preparing the table. This is a little bit of a longer operation because it gets all the orders, then it sorts them by field, and then it again filters them for a second time by date to get the last 10. But you can see it's nicely formatted. You can do a lot of also permutations to this. And for example, if you have some secret sauce algorithms, you can go back and forth from Excel to the LLM to an application in the workspace, which we're going to do now. So I'm going to paste some tickers that I'm interested in, and I'm going to ask the LLM to create a watch list from the tickers in my spreadsheet. And here on the bottom left, you have the watch list application. And again, this is a very verbose model. It says it now looks at the Excel, even though Excel is not visible on the screen. It tells us what it sees. It sees a selection between rows A1 and A5. It correctly identified the 4 tickers that I just pasted into Excel. It added them here to our web application as a watch list, and it added some market data in the actual application. And just to round everything back, I'm going to ask it, I'm going to congratulate it and ask it to now add the market prices to them, just to show you that full circle, going out from a web applications to the OM, to the bridge, to Excel and back. And let's open the Excel so you can see it in real time. It already created a new sheet here called market data, got again the 4 symbols, got the market data. Again, this is a backend call, if you remember from earlier in the demo, and now posted it in both times in the actual LLM window, which is a nice design option. We'll have in the following months, I think Bob will touch on it. We'll be talking about MCP apps and whether you want the data rendered into the chat window, rendered in the workspace, or rendered somewhere else, or even hidden. Who knows? But yeah, that's the full loop. That's the demo for today, and I hope you guys enjoyed it.
Thanks, Krasi. Yeah, I think it's just really helpful to see what this looks like in practice. And there's one question in the chat just to kind of go back to the inline question. This is model agnostic. Everything in io.Intelligence is designed to work with the LLM gateway of your choice. So if you're using AWS Bedrock or Azure Foundry, whatever your preferred gateway is, we're inherently model agnostic. We do not provide the large language model. That would be something that you bring to the party. This demo is using pretty advanced frontier models. In this case, it's probably Opus 4.6, maybe 4.7, depending on what we were testing with. But we are doing a lot of experimentation on the io.Intelligence business unit around what's the lowest level of model that can get the job done. So whether that's an earlier model like a Sonnet model from Anthropic, or we're starting to look at local models for tool selection. I think we're very aware, talking to clients, that what we refer to as tokenomics, or just the fact that it does actually cost real dollars or real money to run large language models, is part of the conversation. Certainly, not every workflow is the right one for AI to add value. And so when you get to that point in your evaluation process, we're also equipped to help you with not only the model selection process, but the evaluation process if you should want us to do so. On the demo, Krasi, maybe just to recap for folks in the audience before we move to the architecture, the neat thing here is instead of having a ton of different AI experiences in each application, you actually have a centralized assistant that is aware of the workspace context, It solves the discoverability problem. It knows which applications are available, what they can accomplish, and the actions that can be taken. And those actions are obviously built on top of the io.Connect platform and the methods, the interop methods that exist within there, making them imminently observable and something that you have full control over in terms of what you do and don't want the AI assistant to do. That's an implementation decision as much as anything else. So, for example, your helpful AI assistant can open and even populate a trade ticket, but you may never want it to actually execute that. That might be a human in the loop step. So you have full control over where that line is for your organization in the implementation process. Again, our philosophy is just providing the framework and the scaffolding which you would build onto. There are a lot of decisions that you'll have in the implementation. So you've turned essentially one assistant, an LLM, or multiple LLMs into a universal remote control for your enterprise desktop. You've got the ability to pull data together, so blending it in the LLM's context window to get useful analysis and information. But you can also do more than that. You can take actions across these applications as opposed to just having a question answered by a vector database or something along those lines. So hopefully that's helpful. There's a lot of additional capabilities that we won't have time to show today, but I think this is a good chance to turn it over to Colin and talk about how did we enable this? What does the architecture look like? And what can you take advantage of from an implementation perspective? So over to you, Colin.
All right, thanks, Bob. I'll just jump right in. I'll share my screen, and Bob, if you can give me a hand and let me know when you can see it.
Yeah, we got you.
All right. Now, a lot of cool stuff was said, and Krastev showed us some cool things, but now let's zoom in a little bit on the technical pieces that make all of this come together and function as you saw it on the screen. So as you can see here, this is like a zoomed out diagram of io.Intelligence in general, and I want to tackle this in two pieces. First one, I'd like to talk about the Q4 release that we did last year. Bob already mentioned that, and then I want to jump into the latest Q1 release, which ties in everything together. So last year we set about meeting where our clients and partners are as fast as possible in their AI journey and bringing our knowledge of io.Connect into their already heavy investments in AI. We weren't trying to compete what they're already very heavily invested in. We want to supplement, we want to provide our expertise. That was our immediate focus. So this naturally led us to creating the first two layers that make up our intelligence. The first one is the working context layer, which we can see here in green. And the second one is the tooling layer, which you can see here in blue. So let's zoom in a little bit on both two. Now, in terms of the working context is a very simple technical layer, but extremely cool. This is a JavaScript package, which is available in the public NPM, and it is designed to track information that is already shared by your applications in io.Connect. As you all know, there are so many ways to share data, the apps to share data with one another. In io.Connect, you have application context, you have global context, workspace context, channel context, window context. Everybody has contexts. And it's rich, but then again, also overwhelming. And being able to pass the correct data into the LLM so that the LLM has an understanding of where your user is and what your user is working on, it's quite cool. But we also take data very, very seriously, and we designed our working context layer in a way that we do not track anything and we do not expose anything to LLM unless explicitly configured. And how this is done? This is done by configuring the working context with a schema. Now, I'll give you a quick glimpse of what the schema looks like. This is our docs. It's fully online, so I encourage you to play around with it. So we can go here to the examples, and we can see this is an example of a schema. So it can get fairly complicated, but what I want to draw your attention to is that when we talk about the schema, we're interested in what do you want us to track and where. In this situation, we're interested in the user ID, which is a string, which has some description so that it has some meaning to the LLM. And where do we track it from? This needs to be very explicit. In this situation, we're tracking the possible user IDs that are saved in the global context under the key user session path user.id. This is so we are very, very explicit in receiving instructions of where we're going to track the data and what the data is going to be. Because number one, you get full 100% deterministic control. We're not using LLMs here because we don't want to introduce more unnecessary variables, and you are 100% certain that nothing that you don't want to will be leaked to the LLM. And this then gets fed into your AI assistant in two ways. The first way is it can be piped in to our MCP layer, which I'll talk in a second, or it can be directly added to the front end of your AI assistant or our own that I'm also going to mention. So how does this look in practice? Here I have something that you saw previously now with Krasi. I have an io assist running and I don't have anything opened. So I'm just going to type in who is my client. And naturally, it wouldn't know. Like, based on the working context, there is nothing you can tell me, yada, yada. Basically, the LLM doesn't know. And that's great. How would he know? He wouldn't know. But then I'm going to open up an application. In this situation, I have a client selector application. I'm going to open it in the same workspace. And I'm going to select John Smith. And now I'm going to ask it again, who is my client? And as you can notice, now the LM knows who my client is. And this is a very hello world example, but it starts to paint the picture of now the LM all of a sudden understands relative terms that the user will be talking to. The user is not going to be saying, I would like you to open the portfolio of client C-12345, because nobody knows the IDs of the clients, and there may be many John Smiths here. But in this situation, the user doesn't need to because the LM knows where the user lives in. And that's extremely powerful because it can work with the currently selected application, the currently selected workspace, the channels, the global contexts, everything. It's a very simple but yet very powerful piece. The next piece that we shipped last year was the MCP layer. Now, this is our tooling layer, and this is where we really drove what io.Connect can do to its core, to the LLMs, in the shape of tooling. At the center of our layer is our MCP core package, and this is a package available in the public NPM. On the left side, the MCP core package exposes MCP compliant server instance. So we're 100% MCP compliant, with the standard. And this means that you can consume that with any MCP transport that you desire, or you can use one of ours. And we've designed two transports. The first one is our MCP HTTP transport, which, yeah, the name speaks a lot, and it's designed specifically to run as a service application in Connect desktop. But we also wrote a custom transport, which we called MCP Web, which is built on top of the io.Connect transport logic. And this allows you to have your MCP server running in your io.Connect browser platform on the front end without any external deployments or installations. And is going to be consumed by any io.Connect client. So in essence, you can have MCP servers without external deployment. And that's our own transport here. Now, that's how you can consume it. But let's talk about what do you get. The first thing that you get is we made it easy for the LLM to understand the capabilities of your applications. And we do that by leveraging the already known io.Connect interop methods and intents and also FDC3 intents. So we offer ways for dynamic and intent-based and interop-based tools to be registered. The first one is the dynamic tools. A dynamic tool is basically a special interop method that any connected application can register, and that will be picked up by our MCP core, and it will be exposed to the LLM as a tool. Now, that sounds a little bit too much, so let me show you in practice. Now, here, let's go back to our example here. And first, when we click on the icon here, you can see all the tools. You can see a bunch of tools, but there is no greeting tool. Let's add a greeting tool. I'm going to go again to the docs, and here under MCP core, we have the tool types. And let's go to the dynamic tools. And I'm just going to copy this snippet because I want to do it live so you don't think there is some programming lies going in the backend. So what I'm going to do now is our register and interrupt method. You know that you've done that a million times. It's a regular interrupt method, which has a name, description, and this is the important bit. It has some flags, which instructs our MCP layer on understanding what this tool is, the name, the input schema, the output schema, and here we have the callback that will be executed by the master application in this sense. So when I register this method, let me just get this out of the way. Now when I open, oops, we see now IO greeting tool all of a sudden. So nothing got rebuilt, nothing got restarted, just an application executing its business logic and exposing it. And now the LLM knows that there is a tool like that. So let's use it. And let's actually combine it with the working context. Can you greet my client, please? Right, need to be polite. So, and we immediately see that the greeting tool gets picked up. It gets picked up, the LLM calls it and calls it with John Smith. So this is how the working context and dynamic tools start to come together to build a more intuitive flow, leveraging what io.Connect knows and can do. The problem, not so much the problem, but the downside with this approach is that, as you can see, the control over how many tools are registered and what is their metadata lies completely within the responsibilities of the applications themselves. That has some cool implications, but also it has potential downsides. You can introduce, you will not have control over the amount of tools or the quality of their definitions if you don't have any control in place. So what you might want to do is you might want to still leverage the interop as an execution to delegate it to a different application, but you as the administrators of your AI environment might want to have control over how many tools and how they're defined. So you might want to be somewhere in the middle. And this is where our static tools come into place. Static tools are tools that are defined in the MCP core upon startup, and this is how a static tool definition looks like. So let's break it down real quickly. I'll leave the availability to the side for now. We have a name, pretty self-explanatory. Description, yes, every tool needs to have a description. Input schema and output schema of the data coming in and out. And here we describe when this tool gets called, who is going to actually execute it. And we're going to execute a method with this name, this timeout, and obviously we have control over which applications are even allowed. So in this sense, you as the AI admins, you're in full control of the amount and quality of the tool definitions, yet still delegating execution to the apps running in io.Connect. And that gives you great control, but also limits a little bit of your flexibility, so to speak. And the same also can be applied to intents and FDC3 intents. So this is how we expose application functionality to the LLM. But that's not all of it. We also ship some tools out of the box with our MCP core package, and we call them system tools. The system tools are a collection of 4 tools, right here, which are split in 2 categories, searching and starting. So in essence, we designed smart composite tools that are, in the searching case, are designed to accept the user input, basically what the user wanted to do. And then we combine all of the knowledge that io.Connect has about your applications and your workspaces and respond with a simple response, which is, yes, I have found those applications that can single-handedly or collectively satisfy the desired intent of the user, or there aren't any. And more important than that, how are they going to do it? Because imagine that you want to do work X and we find an application that does work X, but that application needs data. For example, in order to do work X, it might need to know which client are you working on. And that's another question that the tools answer. They answer what applications will satisfy the intent and how do they expect the data, so that the LLM is then equipped with all the knowledge to make the next decision, which in most cases is to call our starting tools. The starting tools they not only start the applications that were requested, but also passes the data that they expect in the correct way. For example, as a starting context, or as a channel context, or as a window context, or whatever it is their interop plumbing designed to do. And I'd like to show you a little bit of a more advanced situation of this demo, so that will highlight this. So let's go right in and start a new session. I'm still gonna have John here selected, and I'll just use my cheat sheet to send this prompt. So I need to review my client's portfolio performance and check if we need to rebalance based on the target allocation. So here we see a lot of pieces. We see my client, who my client is, well, will depend on the working context for that. And I know I need to do some work, but I didn't specify what applications do I need, what are their names, what's the shape of the data, where do I want to get data, none of that. I just want to do this work. And just mind you, this is not a simple 3-app environment. This is a very feature-rich environment with a lot of applications here. So I'm not choosing 3 applications out of 3 here. So let's run this and see how it goes. Right, very helpful. We pick up the working context, and first we search in the workspaces. Well, we don't have a workspace, so let's delve deeper into the applications. So now we are searching into the applications, and let's see what we'll find. Okay, we found 3 apps that together will give you a complete view of yes, yes, yes. I have those 3 applications, and also, yep, the context is ready as they expected. But how does this look actually? If we zoom in into how the tools were called, the searching tool of the workspaces got the user intent and responded that, well, we cannot satisfy that. Great. But then the agentic loop kept going, and we went and searched to the applications. And here we found applications that do the trick. And I just want to draw your attention to the apps that were found. Here we see the name of the first app, description, that's not important. And this is the magic piece. This is the interop piece. We understood that this app reads context from the workspace, and this context follows this schema. So apps reported their interop plumbing and the shape of it. LLM was able to understand that and bring it together with the knowledge that it has via the working context. And as a result, it's ready to do the job. So would you like me to create a workspace? Yes, please. Let's go ahead. No typos. So let's see. Yep, I would like to have workspace. Oh, I misclicked there. And as we can see, I get my workspace. I got the 3 apps and I got John Smith in all 3 of those. And that's how our system tools tie in to the working context. And this is what we delivered at the end of last year. This is how we met all of you that already made significant investments, that you already had your assistants, you already had your backends, but this was our way to kind of bring our source and our knowledge of connecting apps and data where you already are. But this was just the first step for us. We wanted to bring the whole piece. What you see on the screen is a chat assistant that we call io Assist. So it's a complete chat assistant, as you saw now that I've shown you, and Krasi also. It has here all of the stuff that you expect with messaging history and so on and so forth. So we wanted to have packages that offer to get you started and build everything from top to finish, from the UI to the front-end runtime logic, obviously the working context tooling, all the way to the server side. And this is what we call the core io.Intelligence layer. Now let's zoom in on that. The core io.Intelligence layer is composed of a few things. On top of it sits the io Assist visual layer. This is what you've been seeing here on the screen. This is the io Assist chat application. It is a very simple, very thin UI layer. It has all of the UI UX logic, styling, buttons, slide out screens, and so on. But it's very lightweight, actually missing any of the AI specific logic. And we deliberately designed it this way because all of the AI specific logic is in another module, which we call io.Intelligence AI Web. This is a front-end package available again in the public NPM, which is our front-end runtime environment. This is the piece that is responsible for connecting to your agentic backend, connecting to multiple MCP servers. It can connect to our MCP servers via all of the transports, or it can connect to any compliant MCP server out there. So it's also a multi-MCP host, and it's all obviously io.Connect client. And it has also built-in system prompts that we have prompt engineered to work best with the knowledge of the working context and our system tools, so that everything is being used efficiently. On the left side, what you get when you use this package is you get an API. You get the agentic API that gives you access to the agents. You can stream responses, get your trading API, the CRUD operations that you expect, working context API, tooling, all of that. So this is the brains of the front end that allows you to have any chat application or any front end that you wish. That's how we detach both layers. So we understand that some people will want something out of the box, and they're more than welcome to grab IO Assist, which is ready to go, or there are people who would like something vastly different. It might not even be a huge application, but they still want to all the goodies here, and we can accommodate both, because AI Web is not opinionated. It can be used in any framework, and it can be used to create any UI with it. So you can have your cake and eat it too. The next bit, which is in the release, was, let me zoom in here. It's our io.Intelligence server. Now, this is, we didn't go about and create a whole agentic backend, because that is a lot. Instead, we decide to go with a very feature-rich and established framework called Master AI. Master AI is a TypeScript first framework for building agentic backends. So we use that as a demo, but we didn't want to have our clients constrained to, whoops, that was a lot of zoom. We didn't want our clients constrained to just using Master. So instead, our front end, AI Web, talks to the backend using another protocol called AGUI. AGUI is a very established protocol pioneered by the Copilot Kit guys, who describes how the front end and the back end of an agentic system can communicate based on events. So both our front end and our back end talk AGUI. So our AI Web is able to talk to any AGUI backend. If the backend is not AGUI enabled, just out of the box, just like Master is, we provide plugins so that we pipe everything that it's needed, so that that backend all of a sudden talks AGUI. But we do like Master because it's very, very feature rich. Now, that was a lot of talk, and that kind of unveils a little bit of what you've been seeing by me now and by Krasi. But I want to kind of bring home with another demo, and that's our latest addition in terms of standards into the framework, and that's MCP apps. MCP apps is another standard which tries to solve the problem of having boring text. And I'll show you what I mean by this. Let's close all of this, and let's just open io Assist in a standalone application window, just like that. So it's not in a workspace. Let me log in. Okay, so now what I want to do is I want to go through a visionary scenario where I'm planning a vacation. It's fun. I want to plan a vacation with you guys. You seem fun. So yeah, I'm wondering, where should I go? Maybe London, maybe Toronto, maybe Miami. Well, let's see what is the weather in Toronto, right? And the important bit is what we see on the screen. We see text. But now I'm asking, what's the weather in Toronto? And we get as a response, yeah, more text. The weather in Toronto is cold, but this is MCP apps. This is effectively a UI widget, an HTML, if you will, that's get rendered into the screen. That's how the MCP apps work. This is the latest and greatest from OpenAI apps and all of the other frontier models, basically bringing external applications into the chat window to enhance UI, UX, and also functionality. And here I can see the weather in Toronto. But I'm wondering, what about the weather in Miami? So let's see, because I want to compare. Do I go freezing, or should I go sunbathing? Now, I know the answer to that one. So let's see how those stack. yeah, I get the widget. I have Miami here. I have Toronto here. But you can get the idea. Scrolling up and down, this is just, it's so bad. So but this is how MCP apps work. But we actually went a step further. So let's open IO Assist here in the workspace and see what will change. Logging in. Now let's run the exact same flow real fast. Oh, you know already what this guy will say, so let's prepare the next one. Available destinations, where do I prefer? Let's see the weather in Toronto. Now, because io Assist is in a workspace, all of a sudden we have workspace tech. So instead of rendering the app into the canvas itself, we can actually dynamically change the workspace around us to render the apps in the workspace. So we have more screen real estate. And now I see my widget tab beautifully on the side. And when I start working with more complex flows and I introduce other things that require more of the same app or maybe different ones, I have space for them. In this case, I want to see the weather in Miami. And I'm prompted because we know there is already the same MCP app. Do I replace it or a new one? I want a new one because I want a side-by-side comparison. And now, as you can see, I have both my widgets here. I can do my work on the left to continue iterating, or I can do comparisons. And that is really how we went a step above with the MCP app standard to leverage our workspace tech to give you more space for your apps to live and also communicate back to the LLM, because MCP apps, they can talk to their host and they can send prompts. In this case, I'm going to be booking the flight to Miami. So that's great. And let me just click the book button. This will simulate booking and will send instruction to the MCP app that it's no longer needed, and we will be able to clear it from your view, just like that. And this is again something that's not possible in the regular MCP apps standard, because they're always rendered in the canvas, the chat canvas, whether you need them or not. In this case, it's much more dynamic, it's much more fluid, it feels more io.Connect. So those are just standard MCP apps, and we support MCP apps that follow the standard through any MCP server out of the box, and this is driven entirely by AI Web. But we also went one step further with another release of our MCP core in the system tools. We shipped our own first MCP app, and that's a workspace widget. So let's go quickly back to the scenario that we've been running with the client allocation. But for that, I'm gonna be needing a client like that. So let's run the same one. And previously, if you remember, we found some applications, we didn't find some workspaces, we're not gonna find any again. We found some applications and we were able to immediately launch the workspace. And that's great, but launching the workspace can sometimes be an expensive operation. And maybe you sure you want it, maybe you're not. So let's change it a little bit here. So would you like to create the workspace? Well, this is nice, but can I get a preview, please? So maybe I want the workspace, maybe I don't. And all of a sudden we get a preview. This is our built-in widget, workspace previewer and builder, that comes out of the box with workspace, with MCP core. So whenever the user requests a preview of what they're gonna get, we're going to render it just like that. So they're able to see the three applications, how they're going to be stacked and arranged. I can go ahead and build the workspace. I can change it a little bit. For example, I want the rebalancing tool here, or I can work with the AI to enhance it. For example, this client selector here on the left, I would like to have it. So this is nice, but can I have the client selector in the layout too, please? So first, we're going to need to find the actual name, the application name of the client selector. And we found it. And now we're going to call again the widget. And I'm going to get prompted saying, hey, do you want the same app or do you want a new one? Because I might want two versions of the same widget. In this case, I want the same. I want to replace it. I don't need multiple builders. And we're going to go ahead and replace. And now I have my client selector here. added. And I can continue talking. I can say things like, but task allocation is more important to me. Can you make it bigger? And LM will dynamically construct the workspace layout to fit what the user wants. And once I'm happy, I just click build workspace. And then we begin the workspace creation. But in this time, yeah, do you want the context? Yes, I want the context. Thank you for asking. So now the LLM has all the knowledge, but it needs to do an expensive operation. It needs to actually build a complicated workspace layout on the fly. And it actually did it. As you can see, we have the apps exactly how we arranged them. We have John Smith here, we have client selector, and it works. They're piped just like any io.Connect app. And just like that, you can have your working context, you can have your system tools, enhanced UX with MCP apps, and so much more because MCP core understands the interop of your applications and can pipe them in to any AI. And with that out of the way, bring it over to Bob to share our next steps and bring it home.
Yeah, thanks, Colin. What a great demo, and not lost on me, and hopefully not on the audience either. That was all live, so you're a brave demoer, but really helpful to see this in practice, and hopefully it gives you some insight into why we've built what we built, our philosophy of meeting you where you are, and the investments that you've already made in io.Connect and your desktop are now things that you can leverage with AI. So one of the questions that we usually get is, well, how is this different than maybe any other agent or chat assistant like Cowork, for example, from Anthropic, running on the desktop? And it's really about the seamless nature of which it integrates into the io.Connect ecosystem. Those assistants don't know your catalog of applications. They don't know what those applications can do, and they don't know how to orchestrate things like a workspace to actually make the AI experience useful. And so you're seeing a lot of actions being taken. I think the other call out that I would just quickly make, there's a lot of noise right now in the market around things like computer use, which is essentially the idea that AI could see everything that's happening on your desktop and screen. And that's pretty cool if you've seen a demo of it, but it comes with some real challenges around governance. So everything that Colin and Krasi showed you today are explicitly permission capabilities that an AI can take on your user's behalf, and you control that. So, for example, the assistant can never place an order if you don't allow it to do that. These are API endpoints and methods that have been registered from your applications and those capabilities, and that's very governed and very controlled, and you have full control over that, in addition to being able to play the tape back and say, what did happen here? Because this is built in the io.Connect platform, observability as a first-class citizen. And so the overall package here that Colin showed hopefully starts to unlock the art of the possible for you. But if you've made all these investments in interoperability in the platform, you may be further ahead than you even realized in terms of introducing useful AI capabilities to your users. So I'm just going to quickly take a look ahead. So the good news is we've spent a lot of time in the last 6 months building out this product set that you've seen today. It's generally available. And if you like what you saw, I would encourage you to check out the docs, which we'll link at the end of this presentation as a follow-up. And also, if you want an additional conversation with our io.Intelligence team, please contact us through your client success manager. Every instance and situation is specific. And so there's a lot of nuance in this AI conversation, and we're happy to bring that expertise from our work with clients on this topic. Looking ahead, what are we working on next? Really, the three topics we're picking up in Q2 and Q3 of 2026 are around more efficient usage of large language models. I mentioned tokenomics earlier in this webinar. This is a real consideration for all of us. How much is it going to cost to introduce AI alongside my applications and for my users? And so there's a couple of features that we think are going to be helpful here and potentially greatly reduce the amount of token usage in the type of workflow that we just showed. The first one is code mode. And I'm just going to skip a more specific slide here. And this is a pretty simple concept, but very powerful. In addition to the IO Assistant, we're going to ship a local sandbox that lives on your desktop that will allow your assistant of choice, or IO Assist if you're using our assistant, to actually write code using a large language model. So large language models are best at writing code. They've been trained on a large corpus of coding examples. And so instead of just invoking tools, you actually have the ability to allow a large language model to write a scripted program that can then be executed. And early research by us and others indicate that this could drop token usage by as much as 80%. So a lot of the work is done, it's pre-written, and potentially we believe that some of these work products will not even need to require AI to run them after the first iteration. So almost using AI as a builder for the end user. So code mode for us is a sandbox that we're going to introduce that allows our assistant with the LLMs that are provided to it to write code and then execute it. So I think that'll be really, really helpful and is the direction of travel for token efficiency. We also are seeing unique challenges in users operating these types of assistants over the course of a business day. So 8 to 12 hours of work, context window management, compression, really taking care of and stewardship of the context window is something that we're working on. So we're just introducing a lot more capabilities on that front. And then we're expanding our hotel capabilities. It's neat to see this in practice, but as I think everybody on this call knows, supporting this in a production environment requires the ability to really explain, to the extent that you can with AI, what happened across what applications. And so we already have the IO Insights product line for io.Connect. We're just extending some of those capabilities into the AI space. Looking even further out, I think it's largely around just agentic workflows. So not the assistant, but ambient agents that are listening to notifications or events and being able to deploy those successfully alongside assistants and humans. We'll be spending a lot of time on that front. So exciting roadmap. We're going to open it up for Q&A here, but a couple of quick call outs and call to action. The docs are available. We have some additional blog posts in our developer community that we will engage with and are hopefully helpful to get you started. And then for those of you that are based in London or can make it to London, we're actually having a dev meetup on June 4th where Colin, myself, even Ivan Pedoff, one of our consultants from the io.Intelligence team, will be doing a lot of hands-on workshopping. So getting your hands on the NPM packages, showing you how to build assistants, giving you some notes from the field, really kind of rounding out this topic. So thanks so much for your attention. We'll open it up for questions, and hopefully you found this to be useful and really gets the art of the possible flowing. Okay, we got one question in the chat here, and again, feel free to drop them in there if you've got any. What are the challenges that we've seen in implementing io.Intelligence? It's a good question because it's a broad topic, right? It covers AI in general. How do you just get comfortable when everything to date has been deterministic and it's a new concept? It's got costs associated with it. The most basic thing that we've seen success with is what Krasimir showed, which is applications side by side with an assistant where you can actually link back or understand the data that the assistant is providing to you. So there's a lot of robust practices in the background around model evaluations and putting in benchmarks so that you know that there's a level of quality that's been met with any AI product that you're rolling out. But for us, from an end user perspective, you start to see the adoption pick up when you can actually start trusting the answers. So a demo that says AI is going to blend data from two different applications into a work product is cool. You have to trust that data. And so one of the most basic ways to do that is to be able to eye check back to the front end application that the data was sourced from. So we've seen a lot of benefits to that pattern. Just going back to the earlier point, a lot of this is tied into your AI strategy. Where we've seen a lot of success has actually been thinking of AI not always as a centralized mandate or some AI team or a center of excellence sort of mandating everything, but for the interop clients, especially on this call, you're the builders. You're the ones that are actually closest to the end users. You're shipping on a monthly basis to your platform applications and features. And I think that's really where value is added here. And so hopefully you've seen with the io.Intelligence product line that we're meeting you right where those investments are. Everything we've done is customizable and extensible and explainable, but I think it's really focusing on introducing AI alongside the existing applications and work that's being done, as opposed to coming down with some brand new build that's disconnected from that ecosystem. Great. If you do have any other questions after the webinar, please shoot them over. We'd be happy to take them. But we are at time. So thanks so much for your attention. We're excited to share more about io.Intelligence as we move forward. Thanks, everyone.